Good morning, children. Good morning, Swati. Good morning, Bhavishya.
Good morning, ma'am.
Good morning. Yeah, so last class, yes. Yeah, so yeah, Bhavishya, you want to say something?
No, ma'am.
Okay. All right. So last class, we discussed the areas. Now we know that a cuboid has 6 flat surfaces. Both a cube and cuboid have 6 flat surfaces. In the case of a cube, all the 6 surfaces are squares. So the area of each surface, now supposing this is a cube, area of each surface will be a square because each surface is a square. So area of each surface will be a square. So 6 surfaces, 6a square. 4 surfaces, 4a square. 5 surfaces, 5a square. In the case of a cuboid, we said the 6 faces of a cuboid are front face, back face, front, back, the side faces, and the top face and the bottom face. Front face, back face, the side faces, the 2 side faces, the top face and the bottom face. Now tell me, Swati, what is the area of the front face? Can you see the object I'm trying to show?
It's L into height, length into height.
Yeah, both of you are you able to see the object I'm showing?
Yes, ma'am.
Okay. Yeah, so the area of the front face is length into height. So, Bhavishya, what is the area of the back face?
Length into height, ma'am.
L into H. Swati, Bhavishya, what's the area of the side face? The side face.
Breadth into height.
Breadth into height. And Swati, what is the area of the other side face?
Breadth into height.
Breadth into height. And tell me the area of the top face. Top face.
Breadth into length, ma'am.
L into B. And what is the area of the bottom face?
L into B.
L into B. So you're clear with this. Very good. Okay. And we also understood the formula. I also told you that there are 4 vertical surfaces. 4 vertical surfaces and 2 horizontal surfaces. Now, when you take a room, a cuboidal room, the 4 vertical surfaces are the 4 walls, the surface of the 4 walls of the room. The ceiling and the floor are the 2 horizontal surfaces. The ceiling and the floor are the 2 horizontal surfaces. The 4 vertical surfaces are the 4 walls, the surface of the 4 walls. So when we say the curved surface area of a cuboid, we have to find the area of only the vertical surfaces. Curved surface area is only the area of the vertical surfaces. So it's only the area of 4 walls. It's only the area of 4 walls. I've given you the formula for that. We understood how the formula is derived. And the total surface area, meaning the area of all the 6 surfaces, which also, you know, we've derived the formula. We've understood how the formula happens. 2 of LB plus BH plus LH square units. Okay, so that was a short recall of what we understood in the last class about the formulae related to a cuboid. Now let's answer these questions. An aquarium is in the form of a cuboid whose external measures are 80 centimeter by 30 centimeter by 40 centimeter. That is the length. It's always in the order length, breadth and height. It's always given in that order length, breadth and height. You cannot change this order. It's always L, B and H. The base. So you understand which the base is. The base of the aquarium, this one, the base on which the aquarium, stands. The base is the the surface on which the aquarium stands, you know. So the base side faces. How many side faces, children? How many side faces? Two side faces. Okay. So the base is surface. The bottom is one surface. Okay. Side faces, the two side faces, and the back face are to be covered with colored paper. So now which one is, left out?
Mom, the front face.
The front face and
The top face, mom.
the top face. Yeah, the front face and the top face. Because if you cover all the faces of the aquarium with colored paper, then you cannot probably look through the aquarium at all. You cannot see the fish in the aquarium. So the top face and the front face, the front and the top face is not covered with paper. The base, that is one face, the side faces, so two faces, and the back face, four faces are covered with paper, colored paper. So the front face and the top face, they are not colored. Okay. Find the area of paper needed. Find the area of paper needed. So now tell me, you'll have to find the areas of the surfaces separately. You cannot use, there is no formula like, you know. So how do you find the area? How do you find the base area, children? How do you find the base area?
Mom, L into length into breadth.
L into B. Very good. And the side face, one side face, how do you find the area? One side face?
Height into H, mom.
B into H. B into H. So into 2. Into 2. Because two side faces. No. B into H into 2. So all this you should write by yourself. So there is no standard formula. According to the situation, you need to understand and write it yourself. The expression, you know, which is to be used to calculate the area, that you should write it for yourself. And then the back face, what's the area? How do you find the area of the back face?
L into H, mom.
L into H. Very good, very good, very good. Yes, children, that's what you see here. Please write down. Please write. Write down the question. Let me know once you're done.
Completed, mom.
Very good. What about Swati? So the total area of paper needed is 8,000 centimeters square. Any questions, children?
No, ma'am. No, ma'am.
Very good. Done, Swati? Can we go to the next one?
Yes, ma'am. It was completed.
All right. The internal measures of a cuboidal room are 12 meters by 8 meters by 4 meters. Length, breadth, height. Find the total cost of whitewashing all 4 walls of the room. All the 4 walls of the room if the cost of whitewashing is rupees 5 per meter square. Now, let's not read the question ahead. We'll try to answer this. Okay, we'll try to answer this. So we are given the dimensions of the room. So simple, we know the length, breadth, and height of the room. So we can answer any question. For a cuboid, you only need these values. If you know the length, the breadth, and height of the cuboid, you can answer any question with respect to the cuboid. Okay, now what should we find? Total cost of whitewashing. The 4 walls. The 4 walls. So that means the curved surface area. Area of 4 walls is nothing but the curved surface area. So you will have to use a formula for the curved surface area. Now, if you have to find the cost, now supposing now the fruit seller, and if you have to find the cost or the amount of money you will be spending on fruits, first you should decide how much you're buying. You cannot directly decide how much you will be spending. The fruit seller is at your door and you cannot decide how much you're going to spend. First, you'll have to decide what you're going to buy from him. So you buy 2 kgs of apples, half a kg of this, half a kg of that. So based on what you purchase, you will have to find the total cost. Similarly here, to find the cost of whitewashing the 4 walls, you need to first find what area you're whitewashing. You cannot find the cost straight away. What is the area of the 4 walls? Once you find the area of the 4 walls, then you can find the cost. 1 meter square costs 5 rupees. So now supposing the 4 walls have an area of 100 meters square. So 1 meter square will cost 5 rupees, like 1 kg, 20 rupees. 5 kgs, 5 into 20, 100 rupees. 1 kg of fruits, 20 rupees. 5 kgs, so you want to buy 5 kgs. So 5 kgs, 20 into 500 rupees. Similarly here, to whitewash 1 meter square, you have to spend 5 rupees. To whitewash 2 meter square, you'll have to spend 10 rupees. 3 meter square, 15 rupees, and so on. So what area, what is the area of the 4 walls? What is the surface area of the 4 walls to be distempered? That you should first find. And then that into 5 will give you the cost. Next part, what will be the cost of whitewashing if the ceiling of the room is also whitewashed? So if the ceiling is also whitewashed, there's an extra area. What's the area of the ceiling? What's the area of the ceiling? What's the formula to find the area of the ceiling?
Length into breadth.
L into B. So you should find that area. You should first find the area. Like you have to first decide what you're going to buy from the fruit seller. How much are you going to buy from him? Only if you decide how much you're going to buy, you can decide how much you will be spending. Your cost on buying fruits. So similarly here, you'll have to first find the area. What area is to be whitewashed? That into rate will give you the cost. The rate is given 1 meter square. The rate for whitewashing 1 meter square is 5 rupees. So then you should find the area of the ceiling also and find the total cost if that is also included. So I'll show you the answer slide, children. Just see if you can help yourself. Please go through and then start writing. Done, children?
No, ma'am.
Okay. Please let me know. I'm waiting.
Yes, ma'am.
Yeah.
Done, ma'am.
Yeah. So see how the answer goes. First, we need to find the area of the four walls using the formula 2h into L plus B. 2h into L plus B is the formula to find the area of four walls or the curved surface area of the room. So find the area of the four walls, and the cost of whitewashing the four walls will be whatever is the area of the four walls into the rate. So 160 is the area of the four walls into 5, 800 rupees. Now area of ceiling, L into B, 96 meters square. Cost of whitewashing the ceiling will be area of the ceiling into rate. 96 into 5, 480. So first find the area of four walls and find the cost of whitewashing the four walls. See, first find the area of four walls. Next, find the cost of whitewashing the four walls. And then to answer the next part of the question, find the area of the ceiling and find the cost of whitewashing the ceiling. Now, the question is, what will be the cost of whitewashing if the ceiling of the room is also whitewashed? So you'll have to find the total cost. So the total cost of whitewashing the four walls and the ceiling will be, this is the cost for whitewashing the four walls, and this is the cost for whitewashing the ceiling. So add both, this will be the total cost. Is it clear, children? The answer?
Yes, ma'am.
Okay. So we have to first find the area of four walls and multiply that by the rate to find the total cost of whitewashing the four walls. Then we have to find the area of the ceiling. Multiply the area of the ceiling with the rate to find the cost of whitewashing the ceiling. Then add both the costs to find the total cost. All right. Now this is about a cylinder. All right, so let's understand the formula to find the volume, curved surface area, and the total surface area of a cylinder. Now, when we talk about a cylinder, it's always a right circular cylinder. All right. It's always a right circular cylinder. There are different types of cylinders, but we will be talking only about a right circular cylinder. So what is a right circular cylinder? Radius. Radius, because you know that a cylinder has two circular ends. A solid cylinder has two circular ends. Okay, so the top is a circle. So this is the radius of the circle. The bottom is also a circle. This is the radius of the circle. And this is the height of the cylinder. This is the height of the cylinder. The radius and height of the cylinder will be perpendicular to each other. We are discussing, we are about to discuss only this case where the radius and the height of the cylinder are perpendicular to each other. So right meaning right angle, right circular cylinder, circular cylinder. So right meaning right angle, right meaning right angle. A cylinder where the radius and the height are perpendicular to each other. So see, now another example of a cylinder can be like this. There can be a cylinder like this where, you know, this is like an oval. This is like an oval. And, you know, the radius, this radius and this one, they're not perpendicular to each other. See, this is not perpendicular. It's not perpendicular to each other. So we are talking only about a cylinder where the radius and height are perpendicular to each other. So see here, circular base, circular top, okay? Radius of the top circle, radius of the bottom circle, both will be the same. The two circles will have the same radius, you understand? The two circles will have the same radius. And this is the height of the cylinder. This is the height of the cylinder. The radius and the height of the cylinder, in this case, are perpendicular to each other. Since they're perpendicular to each other, the word right angle, right, circular because the ends are circular. The ends of the cylinder are circular. So circular, right, circular cylinder. So we're going to talk only about a right circular cylinder. So something like this. Like this. Can you see? All right. Yeah. So this is the curved surface area. See here, this is the curved surface area of the cylinder, this one. I'm wrapping my hand over it. See here, this is the curved surface area of the cylinder. This is the area of the circle on the top. This is the area of the circle on the top. And this is the area of the circle at the bottom. So right circular cylinder. Right circular cylinder. This is the curved surface area. This is the curved surface area. Area of the top circle, area of the bottom circle. So basically a cylinder has a curved surface. This is the curved surface. Okay, a cylinder has one curved surface and two flat surfaces. A cylinder has one curved surface and two plane surfaces or two flat surfaces. The flat circle on the top and the flat circle below. Two plane surfaces and one curved surface. That's what a cylinder is made up of. Now we are going to understand the formula to find the volume of a cylinder, curved surface area of a cylinder, and the total surface area of a cylinder. Right? Now, I think I just missed to tell you something else about, the curved surface area when it comes to cuboid. Now, children, I told you this one. Volume is area into height. Can you recall? Volume is area into height. I told you that we'll discuss this in detail in standard 9. But just to give you an idea about what volume is equal to area of the uniform cross section. Remember, area of the uniform cross section into height. Yes or no, children?
Yes, ma'am.
Smati? Yeah, very good. Okay, so that's how we get the volume of a cuboid. Volume of cube. Yes, yes.
Ma'am, I'm Nandana, ma'am.
Hi, Nandana. Good morning. You just
Good
woke
morning.
up?
No, ma'am. I was in internet connection. I can't connect my laptop, so I linked in my iPad, ma'am.
Oh, why, darling? What happened?
A very poor connection, ma'am. Now only I joined at 7:15 itself. I can't do it. Now only I get.
I'm so sorry, ma'am.
Okay, ma'am. You can send me the recording, ma'am. I'll watch it today.
Okay, yeah, I'll share by 12 o'clock. I'll try to do it as early as possible, but before 12, I'll send it today.
Okay, ma'am.
All right?
Thank you.
Yeah.
Thank you, ma'am.
So volume of a cuboid, volume of a cuboid is equal to area of the uniform cross section into height. So the cross section is a rectangle, and area of the rectangle is L into B into H. This is how we understood. LBH cubic units. LBH cubic units. This I mentioned. Okay, now I'm going to say something else. How do we find the curved surface area of a cuboid? We found the area of the individual surfaces and we added. You've understood that. I'll tell you how else it's interpreted. How else the curved surface area can be interpreted. If you look into your books, you can find that how did we find the curved surface area? That is the area of the four walls, the area of the four surfaces. We found the area of each surface individually. We found the area of each surface individually and we added. And we got
4a square.
No, that's for the cube. That's for the cube. This is cuboid. 2h into L plus B. So children, The curved surface area, please remember the curved surface area can also be interpreted like this. Perimeter of the uniform cross section, perimeter of the, see, what am I trying to say? What I'm trying to say is volume is area of the uniform cross section into height. I told you this. Volume is area of the uniform cross section into height. The curved surface area is equal to, this is in general for any solid which has a uniform cross section. This is in general for any solid that has a uniform cross section. Now a cylinder has a uniform cross section. The cross section of a cylinder is a circle. That is, how do you understand cross section? If you stack many circles, identical circles, just imagine you have many discs, circular discs. You have many circular discs, identical circular discs. So all the discs here are of radius 10 centimeters. All your discs are of radius 10 centimeters. Now, if you stack these discs, you place the discs one on the other, like you stack your books. So you stack the circles one on the other. The solid obtained is a cylinder. That is why we say the cross section, the uniform cross section of a cylinder is a circle. That is, if you have many identical circles, if you have many identical circles and you stack the circles one on the other, you stack them up, you make a pile like this, you stack it up. So when you stack up the circles, the solid obtained is a cylinder. Can you imagine that?
Yes, ma'am. Yes, ma'am.
Okay. Similarly, when you have identical squares, when you have identical squares, like you have many squares cut out from a paper or cardboard, or, like not cardboard, shouldn't be thick, so paper or whatever material. Now, when you stack these identical squares, you have paper cutouts of identical squares. Say the side of the square is 5 centimeters. The side of the square is 5 centimeters. Now you stack these squares. You stack these squares one over the other to a height of 5 centimeters. Now in the case of a cylinder, there was no restriction. You can stack how many ever circles you want. You will get a cylinder. But in the case of cube, there is a restriction. You must stack them to a height of 5 centimeters, because we know in a cube, the length, breadth, and height are all the same. So you should stack the square pieces of papers to a height of 5 centimeters, because the side of the square is 5. So that means the length and breadth is 5. The height also should be 5. So you should stack it to a height of 5 centimeters. If the side of the square is 10 centimeters, then you must stack the squares to a height of 10 centimeters. Then the solid obtained is a cube. Can you visualize that?
Yes, ma'am.
You must place it neatly one over the other, not haphazardly, neatly one over the other to a height of 5 centimeters or to a height of 10 centimeters, depending on the side of the square. The solid obtained is a cube. That is why we say the uniform cross section of a cube is a square. And we also understood that the uniform cross section of a cuboid is a rectangle. The uniform cross section of a cuboid is a rectangle, because now rectangle, cuboid, no restriction. You have identical rectangles. You place them one over the other to any height, because cuboid LBH can be different, meaning L and B can be the same, height can be different. So there is no restriction for a cuboid. So you have identical rectangles and you stack the rectangles. You stack up the rectangles. The solid obtained is a cuboid. That is why we say the uniform cross section of a cube is a square. The uniform cross section of a cuboid is a rectangle. The uniform cross section of a right circular cylinder is a circle. When you stack up identical circles to any height, the solid obtained is a right circular cylinder. Now, so that's what we understood. The volume is area of the uniform cross section into height. This I already discussed with you. Volume is equal to area of uniform cross section. Area of uniform cross section into height. Now, how is the curved surface area interpreted? In general, Curved surface area. How is this interpreted? Perimeter of the uniform cross section. Perimeter of the uniform cross section. Let me write it. Curved surface area is equal to perimeter. Perimeter of the, listen to me, don't write now, perimeter of the uniform cross section. Uniform cross section into height. Now we've already understood the CSA, the formula to find the CSA of a cube and a cuboid. Let's just see if we can get it. Now for a cube, okay? So CSA of cube, CSA of cube. Children, what is the perimeter of the uniform cross section? What is the cross section of a cube? Tell me that first. What is the cross section of a cube?
A rectangle. I mean a square.
Square. The cross section of a cube is a square. What is the perimeter of the square?
A squared.
Perimeter, darling, perimeter.
4 into A.
4A. Perimeter of the uniform cross section is 4A. Into what's the height of the cube?
4 meters. Yeah, ma'am.
Height of the cube, A. Height of the cube is A. So what is this? 4A into A is 4A square units. See, that's what we understood. 4A square only. This is the formula, you know that. Now, similarly, we'll use the same thing. We'll use the same thing to understand the CSA of a cuboid. CSA of cuboid. CSA of cuboid is again perimeter of the uniform cross section. What is the cross section of a cuboid?
Rectangle.
Rectangle. What is the perimeter of a rectangle?
2 into L plus B.
2 into L plus B. So perimeter of the uniform cross section is 2 into L plus B. Into height. What's the height of the cuboid? Not height of the rectangle. H. So see here, that's equal to 2 into L plus B into H, or 2H into L plus B. Or you can also, it's multiplication only, no? So you can put the H forward also if you want. Otherwise, you can leave it here. 2 into L plus B into H. That's correct. Or you can also write as 2H into L plus B square units. Square units. So what you should remember is, very good. What you must remember is volume is equal to area of the uniform cross section into height. Curved surface area is equal to perimeter of the uniform cross section into height. Please make a note of this, children. Please make a note of this. Just put this in a cloud. You understand when I say a cloud? Just write this and put a cloud around it. Just put a cloud around it.
Ma'am, you told one formula, no, ma'am.
Yeah.
Area of the uniform cross section. Can you also, for which it is, ma'am?
Volume. We'll write it again. Fine.
Volume of the cuboid.
Volume of any solid that has a uniform cross section. We've already written that. I'll write it again. You write this, I'll write that again.
Completed.
Completed? Very good. Can I clear the screen? Yeah. Okay, let's also write that. This we've already written earlier, but let's just recall. Volume of any solid which has a uniform cross section. Volume is equal to area of uniform cross section. Area of uniform cross section into height, area into height. So now volume of a cube, using this one, how do you find the volume of cube? Area of the uniform cross section. Area of the uniform cross section is, the cross section is a square. The cross section is a square and the area of a square is a square into height a. So a cube. So, and you all know that the formula to find the volume of a cube is a cube cubic units. A cube cubic units. And similarly, volume of cuboid is equal to area of the uniform cross section. The cross section of a cuboid is a rectangle. Area of the rectangle is L into B into the height of the cuboid is H. So LBH cubic units. You can write this again. Just be a practice. Yeah. All right, Shikha. So now let's try to understand the formula to find the volume, curved surface area, and the total surface area of a cylinder. As we understood, a cylinder has one curved surface, and two flat surfaces, which are circles. The two flat surfaces on the top and bottom are circles. Okay. Now, volume. This is a cylinder, children. Right circular cylinder. This is the next heading. Right, because the question is about a cylinder. See here, example 6 is about a cylinder. So let's discuss the formulae to find the volume, CSA and TSA of a cylinder. So give the heading right circular cylinder. Right circular cylinder. Okay. Volume. So how does it look like, right circular cylinder? Okay, so radius and height. Volume of cylinder. Or simply volume. We have given the heading, no? So volume is equal to area of uniform cross section. CS is cross section, children, into height of the cylinder. So what's the area of the uniform cross section? What is the cross section of a right circular cylinder?
Circle.
What is the area of a circle? What's the formula to find the area of a circle?
Pi r square, ma'am.
Pi r square. So pi r square into height of the cylinder, h. So pi r square h is the formula to find the volume of a right circular cylinder. Pi r square h, cubic units. Please write down. I have to clear the screen. So please.
Units?
Sorry?
Don't we have any units for cylinder?
Yeah. If it is centimeter cubed. Yes, nice question. If it is centimeter, then the volume will be in centimeter cubed. If the radius and height are given in meters, then the volume will be in meter cubed. So this is in general. Cubic units is a general way of writing because we do not know the unit. The unit can be centimeter, meter. We don't know. It can be decimeter, hectometer. It can be anything. We don't know the unit. Decimeter, anything. So cubic unit is in general. So in the question, you will be given the radius is say 5 meters, the height is 10 meters, whatever. So then when you find the volume, you should write whatever answer you get, meter cubed.
Yes, ma'am.
Yeah. So square units, cubic units is just to say in general because we don't know the unit. Cubic units because we don't know the unit.
Yes, ma'am, completed.
Very good. Yeah, that was a nice question, Swati. Thanks for asking. So I think others also would have understood. Yeah. Through the diagram also, you can see the cylinder. Okay. So this is how we find. This is the formula to find the volume of a cylinder. Next, cross section. Sorry, curved surface area, not cross section. Sorry, curved surface area of a cylinder. Curved surface area. What did we understand? Perimeter of the uniform cross section. Perimeter of the uniform cross section. Uniform cross section. CS is cross section into height. We just understood this. Curved surface area is equal to perimeter of the uniform cross section into height. Now, what is the cross section of a cylinder? What is the cross section?
And circle.
Circle. What is the perimeter of a circle, or what is the circumference of a circle?
2 pi r, ma'am.
2 pi r.
2 pi r.
2 pi r. Very good. 2 pi r into what is the height of the cylinder?
H, ma'am.
H. H. So 2 pi r h. 2 pi r h is the formula to find the CSA, the curved surface area. Only this one. Curved surface area is only this area. Curved surface area. This one. This one. The curved surface area of a cylinder. So area, no, so square units. Area is always expressed in square units. So supposing the unit in the question is centimeter, it will be centimeter square. If it's meter, it will be meter square. But here when you're writing the formula, we in general say square units. Square units. 2 pi r is square units.
Yes, ma'am, completed.
Very good. Very good. Yeah. You'll have to clear the screen.
Completed, ma'am.
Very nice. Okay. Now, next is the total surface area, children. The total surface area of a right circular cylinder. You have given the heading. You have given the heading right circular cylinder. So TSA is of the right circular cylinder. Now, total surface area is the curved surface area plus the area of the circle on the top plus the area of the circle below. Total surface area, whatever area is available in the cylinder. So it is the curved surface area plus the area of the circle on the top plus the area of the circle at the bottom. So this will be the total surface area of a cylinder. So TSA is equal to curved surface area plus area of base plus area of top. Base circle plus area of top circle. Okay. Now, what is the CSA? We just found 2 pi RH. We just found CSA, 2 pi RH. Plus, what's the area of the circle below?
Pi r square, ma'am.
Pi r square. Yes, pi r square. What's the area of the circle on the top?
Pi capital R square.
No, darling, both the circles are identical. Correct. Nice thought. But when we say pi capital R square, that means the two circles have different radii. The two circles are identical. In a right circular cylinder, the top circle and the bottom circle, they are identical. They'll have the same radius. So pi r square only. Pi r square. Yeah. The top circle and the bottom circle in a right circular cylinder are identical. They'll have the same radius. So pi r square. So this will be 2 pi r h plus 2 pi r square because pi r square plus pi r square is 2 pi r square. A square plus a square is 2a square. Pi r square plus pi r square is 2 pi r square. Now what's common? 2 pi r is common. So what should I write in the bracket?
H, ma'am.
H plus
2 pi r.
No, ma. 2 pi r is outside here. 2 pi r into
plus
what
r.
will be 2 pi r square?
R, ma'am.
R. Because 2 pi r into h will give you the first term 2 pi r h. And 2 pi r into r.
2 pi r square.
2 pi r square. R into r is r square. So 2 pi r square. 2 pi r into h is 2 pi r h. 2 pi r into r. R into r is r square. 2 pi r square.
And then cubic units.
No, area. Area, no? So square units. So you can also write, so sometimes we say 2 pi r into h plus r, or I'm, like I'm used to saying 2 pi r into r plus h. I'm used to saying that. So you can write h plus r as r plus h also. Anything you can remember like this square units, 2 pi r into h plus r square units, or 2 pi r into r plus h square units. H plus r plus h. So the total surface area, the formula to find the total surface area for cylinder is 2 pi r into r plus h square units. Is it understood, children?
Yes, ma'am.
Very good. Yeah. Now I have a question for you. Write on this. I'll ask you.
Ma'am, completed.
Yeah. Now, we have seen, just take the case of a steel cylindrical tumbler. Steel cylindrical tumbler. Okay, so this is a steel cylindrical tumbler. Steel is the material. Steel is the material. Cylindrical is the shape. Cylindrical. Tumbler. Tumbler. You can imagine that, don't see this. You can imagine that. Steel is the material. Steel, cylindrical. Tumbler. I want the expression to find the area of steel used in the tumbler. Area of the steel. Okay, if I have to paint the tumbler all over, I have to paint the tumbler all over. What is the area to be painted? I want the formula. You have a steel cylindrical tumbler. You have to paint the tumbler all over. What is the total area to be painted? I want the expression to find the area to be painted. You can't give me a numerical answer. Yeah.
Pi r square h.
Pi r square h. Huh?
Yes, ma'am.
No, that is volume. That will be the amount of liquid the cylinder will hold. Pi r square h is volume.
Pi r square.
Pi r square.
And pi r square plus.
Pi r square plus.
Never mind. Pi r square plus pi r h.
From where did Nandana get pi r h?
Is it curved surface area plus the area of the base circle?
Perfect. Yes. Yes.
So 2 pi r h plus pi r square.
That's all. Yes. So it's not that these are the only three formulae. You have, depending on the circumstance. Now here in this situation, we have a steel cylindrical tumbler. So how does it look like? You have to visualize that object and understand where all the material is available to be painted and find the area. So you don't have a standard formula for everything. So now the area to be painted, you can visualize. You have to paint the curve because tumbler is open at the top. Tumbler is not closed at the top. There is no material on the top. In a tumbler, you have the steel along the curved surface area and the circular base. The top circle is open. There is no steel there. So where will you paint? You will paint the CSA. That is 2 pi RH. You will paint 2 pi RH. And then you will paint the bottom of the tumbler. There is steel. You have to paint that. So you'll paint pi r square because the bottom is a circle. Pi r square is the area. On top, you will not paint. It's open. No, you have to drink from the tumbler. It's open at the top. So there is nothing to paint there. So area you can always visualize like this. Whenever you have to find area, you can just imagine what all surfaces will you paint. If you have to paint it, what all will you paint? All that area you have to find. So in the tumbler, you have to paint the curved surface area. So it's 2 pi RH. CSA is 2 pi RH. Then you'll have to paint the bottom circle, pi r square. That's all. So this is the formula to find the area of steel in the cylindrical steel tumbler. All of you understand this?
Yes, ma'am, understand.
Okay. Now you all know the straw, right? Through which you drink your juice or tender coconut. The straw is cylindrical. The straw is cylindrical.
Yes, ma'am.
Yeah. What is the area of material in that straw? What is the area of material used in that straw?
And plastic.
Yeah, it's plastic or sometimes it's thick paper. Okay, what is the area of, if it's made of plastic?
Area.
Yeah. What is the area of plastic in that straw? Yes.
Is it 2 pi RH?
2 pi RH. Because in a straw, the circle at the top and the circle at the bottom, they are not closed. It's open. There is no material there. The top circle is open. There is no material. If it is made of plastic or paper, there is no plastic or paper on the top circle. Similarly, the bottom circle is also open. There is no material there. So where is the material used? Only along the CSA. So the area of the plastic or paper, whatever is used to make the straw. Straw is cylindrical. I'm talking about a cylindrical straw. Okay, so the area of the material used to make the straw is, there is no material on top. So top circle, no area. Bottom circle, no area. So where is area? Where is the material used? Only along the CSA. What is the formula to find the CSA? 2 pi RH. That's all. CSA is 2 pi RH. Now, if you understand this, you can answer any question. It's very simple because all values will be given. You just have to visualize and understand, what expression you have to use to find the answer.
Okay, ma'am.
Okay, so let me ask you again. What is the area of material used to make the straw? Area of material in the straw?
Ma'am, pi RH. 2 pi RH. 2 pi RH.
No, look into your book. Look into your book. The area of material in the straw. Area is only along the CSA. Top circle and bottom circle open. No area there. Area is only along the, see, area is wherever material is used, there only there is area. Wherever the material is used, there only there is area. If it's open, what area? There is no material at all. The top circle and bottom circle, they are open in a straw. There is no material used there. And I also told you, whenever it is area, imagine you have to paint. So the straw, if you have to paint the straw all over, where all will you paint? You will paint only the CSA. There is no circle.
2 pi RH plus pi r square.
No, darling, why pi r square? Both the circles are open, right?
One circle is closed. Okay.
No, in a straw, one circle is closed, is it? In a straw.
No, ma'am. You told for the before questions. Right?
That is a tumbler. In a tumbler, the bottom is closed.
Yes.
In a straw, both the circles are open. There's no material. So if you have to paint the straw, you'll paint only the CSA. The two circles you cannot paint because there is no material. So the area of material in the straw is only the CSA, which is 2 pi RH. In the case of a tumbler, area of a cylindrical tumbler. When I say tumbler, I'm talking about a cylindrical tumbler. Area of tumbler is equal to where all you have the steel, where all is the material steel along the CSA. So 2 pi RH. If you have to paint the steel tumbler, you can paint the CSA 2 pi RH. And you can paint the bottom because there also there is steel. You can paint it pi r square. Top you can't paint because there is nothing there. So where all you paint is the area. That's all it is. So easy to imagine. If you can paint something, find that area. So you can paint the CSA of the tumbler and the bottom of the tumbler. You cannot paint the top of the tumbler because it's open. There's no material there. So like this, you have to create the expressions according to the situation. You can just make a note of this. Yeah. All right. So now we have discussed all that you need to understand about a cylinder. So this question you should be able to understand. One more thing, children, before we take up this question. Now, the pillars you see in a temple, the pillars, the right circular cylindrical pillars, which you see in a temple. The pillar is stuck to the ceiling and stuck to the floor. Yes or no?
Yes, ma'am. Yes, ma'am.
The pillar is stuck to the ceiling. It's stuck to the floor. So you cannot touch the top circle and the bottom circle of the cylinder. The pillar in a temple, you cannot touch the top circle and the bottom circle because you cannot see them at all. They are there, but you cannot see because the top circle is stuck to the ceiling and the bottom circle is stuck to the floor. So if you have to paint the pillar in a temple, if the pillars are to be painted, you can only paint the curved surface area because you want to paint the top circle, but it is stuck to the ceiling. How will you paint it? And you want to paint the bottom circle of this pillar, the cylindrical pillar, but it's stuck to the floor. So you cannot paint them. So if you have to paint the pillars in a temple, you can paint only the CSA. Yes or no, children?
Yes, ma'am. Yes, ma'am.
In a temple, the cylindrical pillars in a temple, if you have to paint them, only the curved surface area is available to be painted. We want to paint everywhere, but you cannot see the top circle and bottom circle. So you cannot paint them. You can paint only the CSA. But in this question, they have asked you like this only. The question is find the, find the total cost of painting the curved surface area only they've asked you. Even if they don't say that, find the total cost of painting the area of the pillars. Even if they say area of the pillars, you should find only the CSA. Here they've mentioned CSA. Even if this is not mentioned, find the total cost of painting the area of the pillars. Area of the pillars means only the CSA, only the curved surface area. So see, it's very easy to understand the question. In a building, there are 24 cylindrical pillars. Okay. The radius, now when it's a cylinder, you are expecting two values. You want the radius, you want the height. If you know the radius and height of the cylinder, you can answer any question about the cylinder. When it's a cuboid, you're expecting three values: length, breadth, and height. Then you can answer any question for the cuboid. When it's a cube, you want only one value. What is the edge of the cube? If you know the edge of the cube, any question you can answer for the cube. Similarly, for a cylinder, you're expecting two values. What is the radius? What is the height? If you know the radius and height, you can answer any question about the cylinder. And you have the radius and you have the height. So see, it's so easy. There are 24 pillars. Radius is 28 and height is 4. But the thing is, the radius is in centimeter. The height is in meter. That you should handle correctly. The value, the two values, that is the radius
Ma'am,
and height.
we can convert the centimeter into meter.
Yeah, you can convert centimeter to meter or meter to centimeter. Correct. So the both radius and height should be in the same unit. It can be any unit, but it should be the same unit. So that you should take care. You cannot substitute 28 for R and 4 for H. That's wrong because it's 4 meters and 28 centimeters. So that you should handle. You should have both the values in the same unit. Now, anyways, we have the radius and height. Find the total cost of painting the curved surface area of all the pillars at the rate of rupees 8 per meter square. Now, one more thing to notice, they've given you the rate in meter square. 1 meter square, 8 rupees. 2 meter square, 16 rupees. 3 meter square, 24 rupees, and so on. So what is it? You have to find the curved surface area of one pillar. Because they're asking you to find the cost of painting. It's not about volume. Painting is not about volume. Painting is about the surface area. Painting is not volume. Painting is about area. So you have to find the curved surface area of one pillar. Multiply by 24 to find the area of 24 pillars. The curved surface area of 24 pillars. And if you find the area in meter square, it is easy to find the cost because 1 meter square, 8 rupees. So supposing 10 meter square, it will be 10 into 8, 80 rupees. So let me use the answer slide to explain. Yeah. Yes, children. So see here. CSA of 24 pillars. CSA of 24 pillars, 1 minute. Please write this also, children. Start like this cylinder. Start like this cylinder. Then write radius is equal to 28 centimeters. Please write this. Height is equal to 4 meters. That is equal to 4 into 100, 400 centimeters. Please start like this. Please start like this. Okay. Then CSA of, please listen to me. Then CSA of 24 pillars. See, I always convert the larger unit to the smaller unit because you will not have decimal point then. If you want to convert 28 centimeter to meter, it will be 28 by 100 and you will get 0.28. Always convert the bigger unit to the smaller unit. So 4 meters. Meter is a bigger unit. Meter is a bigger unit than centimeter. Convert that to centimeters. 4 meters will be 4 into 100, 400 centimeter. Now let's find the CSA of 24 pillars. So 2 pi RH is the formula into 24. Into 24 for 24 pillars. So 24 into 2 into pi is 22 by 7 into radius is 28 and height is 400. And we have substituted all the values in centimeter. So the area will be in centimeter square. The area will be in centimeter square. But they've given you the rate in meter square. 1 meter square is 8 rupees. Now we'll convert this area which is in centimeter square to meter square. The area which is in centimeter square, we'll convert that to meter square. Why should you convert? Because the rate is given per meter square. 1 meter square is rupees 8. 1 meter square is rupees 8. So convert the area in centimeter square to meter square. This also we have understood earlier. To convert centimeter to meter, you have to divide by 100. To convert centimeter square to meter square, do that 2 times. Do the same thing 2 times. 100, 100, divide by 100 2 times. So see here, you're dividing by 100 2 times. Centimeter to meter, you'll have to divide by 100. So you can see divided by 100 here. Centimeter square to meter square, do the same thing 2 times. 100 into 100. So then place a decimal point. 4 zeros are there. So 1, 2, 3, 4. 168.96 meters square. Now the cost of painting will be the CSA of the 24 pillars into rate. The cost of painting is the CSA of the 24 pillars into rate. So this one is in meter square into 8 per meter square. And this is the total cost. Please write down, children, and do ask me if you have any doubts. Please start like this. Write cylinder. Radius is equal to 28 centimeters, which is given. Height is equal to 4 meters or 4 into 100 centimeter. 200 centimeter. Please write this and then start writing the answer. Go through the answer, understand, and then write down.
No doubts, ma'am.
Very good. So whenever you substitute the values in a formula, all the values must be in the same unit, either all in centimeters or all in meters. What is preferred is convert the bigger unit to the smaller unit. It's easy to convert. So here meter to centimeter. 4 meters is 4 into 100 centimeters. 4 into 100, which is 400 centimeters. So substitute the radius and height in centimeters. So you will get the area in centimeter square. Now convert that to meter square. That's easy. Convert that to meter square. So centimeter to meter is dividing by 100. Centimeter square to meter square. Use 200s in the denominator. You will put 100 in the denominator to convert centimeter to meter. Now put 200s in the denominator to convert centimeter square to meter square. And you get 168.96 meter square. Now for painting 1 meter square, for painting 1 meter square, it is rupees 8. So for 2 meters square, it will be rupees 16. So for 168.96 meters square, it will be 168.96 into 8. You cannot find the area in centimeter square and then multiply that by 8. That's wrong. See, like supposing you want to buy 500 grams of grapes. You want to buy 500 grams of grapes, and the fruit seller says 1 kg of grapes is say 80 rupees. 1 kg of grapes is 80 rupees. So for 500 grams, it will be 500 into 80, is it? 1 kg is 80 rupees. Now you want to buy 500 grams of grapes. So will it be 500 into 80? What will you do? 500 grams. So you'll have to convert that to kilograms. 500 grams is nothing but half a kilogram. Half a kilogram. 500 grams is nothing but half a kilogram. So 1 kilogram is 80 rupees. Half a kilogram will be half into 80, which is 40 rupees. So you'll have to convert grams to kilograms. So like that, you'll have to convert centimeter square to meter square here to apply 8 rupees.
Yes.
Yeah. 1 meter square is rupees 8. 1 meter square is 8. You cannot use this answer. You cannot use this answer. 1 meter square is 8 rupees. You cannot say 1689 or 600 centimeter square. This one will be so much into 8. How can you multiply? This is for 1 meter square 8 rupees, not for centimeter square. 1 minute, children. Yeah, thank you, children. I was telling you that, yeah, so if 1 kg of grapes costs rupees 80 and you want to buy 500 grams, you cannot multiply 500 by 80. So 500 grams is half a kilogram, is half a kilogram. 500 grams is half a kilogram. So half into 80. Half into 80, which is 1 by 2 into 80, 40 rupees, correct? Yes or no, children? Yeah. Okay. Yes, children. I think we finished this, right?
Yes.
Okay. Yeah, next one. Find the height of a cylinder whose radius is 7 centimeters and total surface area is 968 centimeters square. So we'll first do it together. Don't write anything. Yeah. Now what is given here? The total surface area of a cylinder is given to be, now let's understand something else before this. Now what's the formula to find the total surface area, children? 2 pi r into r plus h square units. Yeah, correct. Now, how many quantities are there in this equation? TSA is one thing. TSA is one. 2 is a constant, so leave it. Pi is also a constant, leave that. Then there is R. Again R, so leave it, and H. So in this formula, TSA is equal to 2 pi R into R plus H. There are three quantities. TSA is 1. 2 is a constant, so leave it. Pi is also a constant, leave it. R and H. There are three quantities. In this formula, there are three quantities or three unknowns. There are three unknowns. When you're given the value of any two, you can find the third one. Supposing a formula has 10 unknowns. Some formula, it has 10 unknowns. When you know the values of 9 unknowns, you can find the 10th one. This formula has 3 unknowns, TSA, R and H. And you're given in the question, you're given the TSA and you're given the radius. So you know the TSA, you know the radius, and we have to find the height. That's so easy. See, you know the TSA, you know the radius. So of the three quantities, we know two of them. So you can easily find the third one. Do you understand?
Yes, ma'am.
Now see this formula. See this formula. Volume of a cuboid. Volume of a cuboid is equal to L into B into H. L into B into H. So how many unknowns? Volume of cuboid, 1. Length, 2. Breadth, 3. Height, 4. So there are 4 unknowns. There are 4 unknowns in this formula. Now, if you're given the volume of the cuboid, the length of the cuboid and height of the cuboid, you can easily find the breadth of the cuboid. So there are 4 unknowns here. There are 4 unknowns. When you know 3 of them, you can find the 4th one. When you know 3 of them, you can find the 4th one. So supposing you're given volume, length and breadth, you can find the height. If you're given length, breadth and height, you can find the volume. Supposing you're given these 3, length, breadth and height, you can find the volume. If you're given the volume, breadth and height, you can find the length. So like that. So very easy. How do we work this? First, write TSA is equal to 968 centimeters square. Now, what's the formula to find the TSA? 2 pi R into R plus H is equal to 968. Correct? Is this correct?
Yes, ma'am.
Now, 2 into 22 by 7 into R. What is R? 7 into R plus H. 7 plus H. H we don't know. We have to find H is equal to 968. Now you'll have to simply solve this equation and find the value of H. Just solve this equation. See, like 7 and 7 cancels. So like that, solve this equation and find the value of H. So when you read the question itself, you should be able to make out in the formula to find the TSA, 2 pi R into R plus H, there are 3 unknowns, TSA, radius and height. You know 2 of it. You know TSA and you know the radius. You know the radius. You can easily find the height. Yeah, work out, children.
Completed, ma'am.
Very good. Since we have already understood how to solve equations, I think you should be able to understand this one. 7 and 7 cancels, and then 2 into 22 is 44. 44 comes for division. 968 by 44 is 22, and when you transpose 7, it becomes -7. H is equal to 15. So the height of the cylinder is 15 centimeters. And we have nothing to convert because here the surface area is in centimeter square and the radius is in centimeter. Supposing the surface area was in centimeter square and the radius was in meters, then you should convert that to centimeter. In the formula throughout, you should have the same unit. Area is in centimeter square, so you cannot convert that to centimeter. That is fine. The unit is centimeter. The unit is centimeter. You can substitute as it is. But supposing this is in centimeter square and this 7 centimeter was 7 meters, then you must convert 7 meters to centimeters. When you use the values in the formula, all the values must be in the same unit, all in meters or all in centimeters. Yeah, you can work this as homework, children, because there are 2 cuboidal boxes as shown on the figure. Which box requires the lesser amount of material to make? This is easy. Just take a screenshot. Leave some place, children. This is the next exercise. Let me see. What is it? Exercise 11.3 from NCERT. Yeah, please take a screenshot. Done, children?
Yes, ma'am.
Yeah, please complete this. Yeah. Now see this one. A suitcase with measures 80 centimeters by 48 centimeters by 24 centimeters is to be covered with tarpaulin cloth. Okay, so looking at the dimensions, you can understand it's a cuboidal suitcase because you're given the length, breadth and height. Because you're given the length, breadth and height, it's a cuboidal suitcase. The length, breadth and height are all different values. So it's a cuboidal suitcase. Cuboidal suitcase because length, breadth and height is given. Now you have to cover the suitcase with a tarpaulin cloth. Tarpaulin is a material. Tarpaulin is a material like canvas. We say canvas shoes, right? The shoes which you wear during the sports day. Canvas shoes, white canvas. So like canvas, the tarpaulin is a material. You have to cover the suitcase with a tarpaulin cloth. How many meters of tarpaulin of width 96 centimeters is required to cover 100 such suitcases? So what you should understand is you must cover the suitcase all over. You must cover the suitcase all over with tarpaulin cloth. So all over meaning total surface area. All over meaning total surface. It's not volume. Volume is if you're putting something inside the suitcase. This is you're covering the outside with tarpaulin cloth. So it's about area. Volume is if you're pouring something inside. If you're putting something inside the suitcase, that is volume. Now this is about covering the 6 surfaces of the suitcase. This is about covering all the 6 surfaces of the suitcase with tarpaulin cloth. So it's not volume. Now volume has nothing to do here. It's area. And what area? Total surface area. Why total surface area? Because all the 6 surfaces have to be covered. So you should find the TSA of one suitcase. Multiply that by 100 to get the area of 100 suitcases. Find the area of one suitcase. Multiply that by 100. That will be the area of 100 suitcases. Whatever is the area of the 100 suitcases will be the area of the tarpaulin cloth required. Whatever is the area of 100 suitcases, area of 100 suitcases, whatever is the surface area of 100 suitcases, will be equal to the area of the cloth required, area of cloth required, area of the cloth required. Please understand this. Find the total surface area of one suitcase. Multiply that by 100 to find the total surface area of 100 suitcases. Whatever is the total surface area of 100 suitcases, that area of cloth you will need. You will need that area of cloth to cover all the 100 suitcases. So the equation you need to understand is the area of 100 suitcases is equal to the area of the cloth required. How much cloth will you buy from the market? That is equal to the area of the 100 suitcases, the total surface area of the 100 suitcases. Now in the market, when you buy the material, it is a rectangle. Any fabric, you buy some fabric from a store. The fabric is rectangular. The fabric is wound around a rod, right? When you buy ready-made garments, you don't know. But when you buy fabric to stitch, you want to stitch your dress. So you buy the fabric from the store. So when you buy the fabric, how do you see the fabric? The fabric is wound around a rod. There's a long rod and the fabric is wound around the rod. So when you say, give me 2 meters, 2 meters of some fabric. So he has a measuring rod. The shopkeeper, he has a measuring rod. He'll measure 2 meters. And when he cuts and gives the fabric to you, when you just spread it open, it's rectangular. The fabric, it can be a square or a rectangle. When I say rectangle, it also includes a square. When you buy the material, any material, when you buy from the market and when you spread the material, it's a rectangle. So supposing the area of the 100 suitcases is, I'm just saying, for example, is 96000 centimeter square. For example, the area of all the 100 suitcases is 96000 centimeter square. That so much cloth you should buy is equal to the area of the cloth. So much cloth you should buy from the market. But if you go and tell the shopkeeper, give me 96,000 centimeter square of cloth, how do you buy fabric from the market? You'll only suggest the length because the width is fixed. Children, I'm talking too much, but you need to understand this. When you buy fabric from the market, you will not tell them the length and breadth. Breadth is fixed already. That fabric breadth is fixed. Please experience that if you have not purchased material, from the market, if you're used to only ready-made garments, please buy. When your parents go shopping, join them and just buy 1 meter of a fabric. Then you will understand what it is. You cannot tell the shopkeeper the length and the breadth. You will only say the length because the breadth is fixed. The breadth of the fabric is fixed. That you cannot decide. You can only decide the length of the fabric. So you can ask for 2 meters, 2.5 meters, 3 meters, 10 meters of fabric. The breadth of the fabric is fixed. That is what is given here. The breadth of the tarpaulin is 96 centimeters is given here. See here, the breadth of the tarpaulin is 96 centimeters. That will be fixed. You can only ask for the length. So the breadth of the tarpaulin is 96 centimeters. So see here. So 96,000 is equal to, how do you find the area of the cloth? L into B. How do you find the area of the cloth? L into B. L into B. Rectangle. So 96,000 is equal to length we don't know into breadth is 96. Breadth is 96. So the length you need, the length of tarpaulin you have to buy is 96,000 divided by 96, which is 1000 centimeters. Just for this example, 1000 centimeters. So if you buy the tarpaulin of length 1000 centimeters, it already has a breadth of 96 centimeters. So length into breadth is area. So you will get an area of 96,000 centimeters square. If you buy tarpaulin of length 1000 centimeters, it already has a breadth of 96 centimeters. So length into breadth is area. Length into breadth. So 96,000 centimeters square. This area you will get tarpaulin. And that is enough to cover all the 100 suitcases. See the answer here, children? since it's time, I'll just explain and you can complete this later. So see here, area of tarpaulin needed to cover one suitcase. Total surface area, all the 6 surfaces you'll have to cover. So 2 of LB plus BH plus LH. Find that. So many centimeters square. So area of tarpaulin needed to cover 100 suitcases will be 100 into whatever answer you got here. So many centimeters square. So many centimeters square. But how do you actually find? So whatever you get here, that will be the area of tarpaulin. How do you find the area of tarpaulin? See, this is the area of fabric you need. This is the area of fabric you need to cover all the 100 suitcases. So that means L into B should be equal to that. L into B is the area of the fabric. L into B should be equal to that. So length into length we do not know. The breadth of the fabric is 96 centimeters. The breadth of the fabric is 96 centimeters. Should be equal to this area. The area of the fabric is also this. The area of the fabric should be so much. So length into breadth should be this. Length into 96 centimeters, which is the breadth, should be this area. So L is equal to whatever this number is, 1382400 divided by 96, which is 14,400 centimeters. Because it's more than 100 centimeters, we convert it to meters. So you divide by 100. So the length of tarpaulin needed is equal to 144 meters. 144 meters. Why we convert it to meters is because it's more than 100 centimeters. 1 meter is 100 centimeters. It's more than 100 centimeters. So we convert it to meters. Divide by 100. So 144 meters. Children, please take a screenshot. We can discuss this answer again in the next class. If you have doubts while working.
Yes, ma'am.
Yeah. So you have to complete 2 answers, children. 2 answers you'll have to complete. One is that cuboid, and then this one. Please complete both by the next class tomorrow. All right?
Yes, ma'am.
Okay, children. All right, children.
Yes.
So that was it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, children. Thank you.
Thank you.